Hi, this is Sudipta. I'll be presenting our work AVLEN Audiovisual Language Embodied Navigation in 3D environments. We consider the task semantic audiovisual navigation. In this task, we consider unmapped 3D house environment and we use SoundSpaces simulator. In the environment, let's say the agent is at location 1 and there is a sporadic sounding object at location 2. For example, it can be door or window opening sound or it can be kitchen sound. And the task of the agent is to navigate itself towards the sounding object. Now, let's say, based on the sounding object, agent starts navigating from location 1 and reaches some point at location 2. At location 2, the agent is kind of lost or like uncertain about what step to take. So we equip the agent with an interaction ability where it can ask for help or query and it will receive natural language instruction from Oracle or human. Based on the natural language instruction, it will take some steps in the environment and it will try to correct its trajectory. After that, it will again start navigating based on the audio goal information and will try to reach the goal. So here we unified audio-visual navigation with natural language instruction, and also the agent is now able to query at any location in the environment. We formulate the task as partially observable Markov decision process. We consider a set of action, taking right, taking left, moving forward, stopping, and also we included query. We consider a vocabulary of language since we are dealing with natural language instruction. Um, our objective is to learn a policy that maximizes the expected return and minimizes the number of queries to the oracle. So there will be penalty whenever agent queries. At any location, the agent has some observations, for example, RGB depth images. It will have sound information if the sound is on, pose information, and previous action information. At locations where agent queries, it will also receive natural language instruction. Since the agent is working with multiple defined modalities, we consider three defined policies the agent works on. The first policy, PyG, navigates based on audio goal information. The second policy, PyL, navigates based on audio goal and language instruction information. And the third policy decides when to query. The policy PyG, which navigates based on audio goal information, can be trained using reward signal, where the reward signal can be distance to goal or correctly reaching the goal. The second policy PyL, language based that operates on language instruction, can be trained using ground truth trajectory, and we utilize instruction trajectory dataset in a repurposed manner to train this. And the third policy, PyQ, that decides when to query, there is no annotation or direct reward signal that we can use to train this. So what we did is that like we set these three policies in an hierarchical manner. In the top level, we have PyQ, and in the low level, we have PyG and PyL. So PyQ first decides if it should query or not. If it does not query, it uses PyG, and if it queries, it uses PyL. Whether it uses PyG or PyL, that policy will take some step in the environment and collect reward. And these rewards can be used to train the entire setup. We compare our approach with state-of-the-art approaches that address the task of semantic audio navigation. None of the approaches use natural language instruction. We showed that with feedback of natural language, we can perform better. Here is a qualitative example where the agent is trying to navigate towards a sounding cabinet. So at this point, the agent is kind of lost. So it queries and gets an instruction, go straight down the hallway. And it uses the instruction to take some steps and finds the opening. After that, it is able to reach the goal correctly. Thank you. Code and pretend models will be released soon.